All right, in principle, we are up and live. Let's check whether we have sound. We seem to. We seem to. All right, sweet. Cool. We are here. We are ready to go. So it is late. It is stormy. I had an operation like 4 days ago, and I'm tired. So perfect time to jump into some optimization and rework. So high level thing, we're working on Glyphos, which is a math processor in the same way that a word processor is a computer program, desktop program for working with words, writing documents, and so on. We should have a math processor. The math processor should let you do math, not like calculations like you do in Excel or on a calculator, but like actual math. And so we've done that. We've built it out, but it's a little slow. So right now it can do transformations. I've demoed it before in its current state. I'm not going to do it this time because frankly there's nobody watching, and that's fine. If you are watching this in the future and you want to see a demo, just go back to the previous VODs and you can see a quick demo. But basically the issue is that right now it's too slow for me to put in any kind of algorithm that looks more than one transformation step ahead. So like a lot of stuff you want to be able to ergonomically do, like say you have, say you've got some sum and it's in the wrong order and also the parentheses are wrong. You just want to be able to apply multiple steps of commutativity and associativity and have it just work. But right now you have to do each of those manually. So what we're doing about that is we are re-implementing SymbolNode, which is, wow, why is this so slow? Close some stuff. Close that. Let's close that. Am I dropping frames? No. Okay. You can see what I'm doing. Okay. Hopefully this speeds up a little bit. So SymbolNode is over here, and this is like our core primitive as far as like statements go. So it's got a root and it's got children, and so if you have like a plus b plus c equals x, then the way it's going to look is like equals, and then on the right it'll just be x, and on the left it'll be a plus b plus c, and then those will be stored in the children, and those themselves are symbol nodes, and so be a plus b and c, and so on. And these are slow because a lot of the algorithms we want to apply to them are getting applied. They're like recursive, and these things aren't going to be particularly well laid out in memory, and so on. So we are going to replace them with binary symbol trees, which look like this. And the idea here is that we have a hash map. So that's still going to be pointers, but a hash map from symbol names, which are just strings, to their roots. And then we have a binary number that tells you where the left parentheses are, a binary number that tells you where the right parentheses are, and for each symbol, a binary number that tells you where the symbol is. And this turns a lot of our recursive functions into not needing to be recursive, because there are things like replace all the instances of x with a plus b, and now I can do that by just updating these hash maps, which do, one lookup and one insertion, and updating the binary numbers, which we can do by sort of tearing apart the number and replacing it in the proper way. And so it just stops being recursive, or at least as recursive. That's the hope anyway. We have benchmarks set up. It's been, a process, but we're getting close to having a lot of the functionality updated or replaced, and then we'll have to actually pipe it, like attach it to the rest of the app. Okay. So let's figure out where we were. So last time we implemented a bunch of functions. These are all good. So let's open up. Let's see here. You know what? Let's actually start by figuring out where, like, we've implemented a bunch of the basic methods that I know we're going to need. Let's go actually plug this thing in. So, where are we going to use, where do we use symbol nodes currently? We use them in transformations because a transformation is just a map. Well, most transformations, explicit transformations, are just maps from one symbol node to another. And then we use them in the workspace. Display stuff here, workspace. Oh, but it's actually the transformation lattice now that holds them, which is fair enough. So the transformation lattice is the thing that stores all the statements and the transformations and says basically, here are the statements that are true and here are the transformations that were used to get us there. So available transformations, and transformations from transformation 2 all use symbol nodes that are all going to become binary symbol trees. And I think I want to start today by just like getting into it. Get status. Let's just make sure. Cool. We're going to clean status. Let's just do it. Let's just say binary symbol tree. And before I totally launch into this, I'm just thinking, so a couple of bad things are going to happen to us. One bad thing is that these are going to serialize totally differently, which might break some stuff. Like, I have integration tests that rely on the serialization. I think it's fine, though. The other thing that I'm thinking about is I think there's a very real chance that we end up in a hybrid world where symbol tree or symbol node and binary symbol node are both used. And we basically, if the symbol tree is smaller than 64 bits, we use a binary symbol tree, and then otherwise we use the symbol tree. Because that way it'll get laid out in memory well, and we can allocate it to the heap. Can we actually allocate it to the heap in that case? This is a question I have. Ask ChatGPT. I'm working on optimizing some Rust code, and I have a complex type that can be of arbitrary size, but is often less than 64 bits. I can represent it as a few 64-bit integers, so E64s in that case, and then have a super type that automatically switches between the fast U64 implementation when less than 64 bits and the more complex type otherwise. Will the 64-bit version get allocated to the heap rather than the stack? Let's see here, blah, blah, blah. Sorry, I meant stack, not heap. I said that backwards. Yeah, okay. And then just looking. Yeah. Yeah, so I mean, I think there's a world where we do a more complex thing here. I don't really want to prepare for it though. Let's just get in there. Let's just get in there. This is going to cause a lot of issues for my tests, and it's going to make everything not compile, but that's okay. We're going to work through it. All right, let's do some proper regexing here. SymbolNode, binary symbol tree. There's a way to repeat this. Yeah. Why is that like that all of a sudden? There it goes. Okay. This is changing a lot of things that I don't love. I'm just thinking about all the find replacing that's happening right now. And like this file should not care about the implementation details. Okay, because the alternative is we can make this into an enum or a struct that just contains, we can call it like symbol tree. I'm gonna need so much boilerplate in that case though. So if we call it symbol tree and we have it be an enum, just like a lot of boilerplate to delegate around. Here's a question. Can I do a disgusting thing? Can I do this? That's hilarious. I can just shadow. Can I just shadow the type name? My freaking IDE is like crawling, trying to figure out what I'm trying to do. Okay, SymbolNode is defined multiple times. Literally, my IDE does not know what to do with itself right now. It's a funny problem to have. Just gonna like give it a minute. There we go. 92 errors. Similarly named type alias. This seems to be working though. Okay, this is great. Oh my god, my IDE is losing its mind, but otherwise this is great. Because now I know exactly what to implement. Namely, we need length. We need toSymbolString. We need isJoin. Let's start here. Length in bits is not the same thing. Wait, what even does length mean for a SymbolNode? It's got to be the total size, right? Yeah, it's the total size. I don't like love that name, if I'm being honest. I thought I had something else for binary symbol tree. Binary symbol tree. Blah blah blah. Has children. Length in bits. Get depth. I want to do like get size. Okay. Is there a way to do this that's faster than recursion, sure. Sure, because we can say self.nodes, node trees, .iter.map. So this is label, which won't matter, and this is encoding. Encoding.count ones. .sum. Oh my god, why is my ID so slow? This is horrendous. Okay. And I'm gonna rename this size. Which I'm a little worried, given the way my ID is behaving, that it's not going to be able to do that, but we'll see. Yeah, okay. Let's go to size. And this is unusable. Okay, this actually doesn't look horrendous. It probably is horrendous. Okay, so then all over my tests, we're gonna have a problem because I do SymbolNode new. Which is definitely going to be a problem. Let's see if I can do this. And then everywhere that does new, does SymbolNode new. Yeah, we're just gonna do a find replace on that bad boy. So anywhere from here to here, SymbolNode new. It's gonna be old SymbolNode new. And then some new stuff is going to yell at us because we're going to need to do a bunch of intos. And all the leaf object stuff too. Leaf object. I guess we can implement leaf object. So leaf object is just like an initializer. So this is going to be self new. A vec from label to symbol node root object. Can I say that? Probably just symbol object label into. Let's go ahead and name these what they are, I guess. Let nodes be this. See. Well, you know what we can do though? That's better. I think we can just say SymbolNode leaf object label into. There we go. That's better. And now in here, leaf object is implemented. It's just called SymbolNode. And that should be all right. All right, to symbol string. We can play a similar game. I don't need this to be fast right now. We can. Oh my god, I do need my IDE to be fast though. This is ridiculous. To symbol string. Okay. Can't find symbol name. Why not? This is painfully slow. Wonder if there's like a cycle in the type dependency or something. Surely you're allowed to do this though. Like, wait a second. What if instead of this, can't I say as SymbolNode? Is this any better? Probably not. It's probably equivalent. Okay. This is unusably slow. Yes, I know you expected a right to Pran. I literally could not type it. Could not type it. Okay, getting a little faster now. What's going on here? Okay, leaf is another thing we need to implement, which will be the same pattern. SymbolNode T. Symbol. Oh, it's so snappy on that page. On this one, actually new is primary. Old. Into old. Into oops, and into. Our symbol tree doesn't implement display. Sure, I believe you. Okay. Old SymbolNode. Didn't I find replace this? Because I only did it in my tests. Probably should have find replaced it everywhere. That would have been faster. What to do? Oh, what would also be faster is if my IDE were faster. How about that? Okay. A lot of garbage in here. This garbage is all going to go away though. Okay, so in principle we have no errors in here, which I find. Use of undeclared type, old SymbolNode. Fair. SymbolNode. Old symbol. Node. Does this work? And then we can get rid of this. Get some super. like stream some video games while I wait for this thing to refresh every time. Okay, so this is the usual bunch of junk that proc macro thinks is wrong, but actually isn't wrong. And this is going much faster. Not really. Somewhat faster though. Okay. I guess we'll play the same game in workspace. So we'll say SymbolNode as old SymbolNode. And we'll say binary symbol tree as SymbolNode. And then everything will bomb out. Oh, too bad. Okay, so we got some new in here. So let's go SymbolNode new. But it has to be not display SymbolNode. Which I forget how to do in regex. Some look behind. Okay, but we can just do this in two shots. We can say display SymbolNode new, old SymbolNode new, and then I think as long as I put C here, then we can say no, yes. Oh, and that's literally it. Okay, I could have done that without a regex. Okay. Cool. This doesn't actually make any sense though. How can this possibly not be breaking? Let's take a look at Cly. This is like definitely the sort of thing you want to be doing when you're tired. SymbolNode. All right, let's wait on this. Let's go back here. Nothing failing. Let's just compile. See what happens. Let me get a water while this compiles. Okay, doesn't compile. We're shocked. Yeah, so even though it's taking A billion years. So that's correct. But then 2. Damn. This is kind of a head scratcher. Symbol, old symbol node, new. Okay, fine, I get it. Whatever. We'll fix it in post, as it were. Like, I'm not gonna keep this type aliasing around forever. I just want to do it now so that I'm making a million changes at once, and then at the end I can do big find replaces. Okay. Let's, surely that's not the only error that came up. Singleton. Sure. Pub function singleton. Symbol, I guess. Okay. What else do you got for me? New from symbol. How is new from symbol different than leaf? Is what I want to know. Oh, it has children associated with it. Okay. That one we can't really do directly. I mean, I guess we could. And then see. Like, do I really want to do this? Maybe. Adding children is like not particularly. I think for now I'm not gonna do this. I think for now, oh god, I saved. I think for now we'll just go workspace 27, 28. And just into at the end of this. Oh, we need an old symbol node also. Oh, I shouldn't have saved. I have a really bad habit of just saving while I'm thinking, and it's killing me right now. because the IDE takes forever to update afterwards. And also, it just times out. Sure, I could just shorten that timeout. And so that means I'm not even getting all the errors. Which is logical, I guess. 1493. To interpreted string. Again, we can just alias this for now. Vector of interpretations. Okay. Same thing is join. Is join. Let's do this. No. True. Otherwise, false. Okay. What else? Generate. Yeah, generate seems like a pretty legit one. What did generate do on SymbolNode? Nothing. Generate wasn't a thing. Oh. That's because generate comes from somewhere else. 1074. Generated types. For now, we'll just say .2. Join. Sure. Oh my god. IDE, let's go. Join. So like this. Alright, so here's where we want self from symbol. but again, let's start with SymbolNode, new, use join, self.into, other.into. These are not really the slow functions I'm worried about. To interpreted string and type map. Mr. IDE, go faster. To interpreted string and type map. This returns. Oh, did this return a result? No, just a string. Okay, this returns a result of a string and then a vector from string to type. Sure. Result. String. Vec. String type. Like that. Did I get that right, or did I miss I don't know. Looks good. Alright. Keep trucking. Mismatch types. Yeah, okay, for now we'll just do this. Borrow of moved statement. Yeah, that's fair. Fine, am I gonna have to do this a lot though? Parse from string, expected. Was I inconsistent in how I set up join? This is sending me to the totally wrong place, huh? Join self other. Takes it by ownership. It's not totally clear that that's necessary, but we'll just be consistent for now. Alright, let's go cargo test again. Getting some errors. Man, I gotta say, I'm gonna be really bummed out if after all of this, we don't get a significant speed up. 1075. So this doesn't quite work. Okay. You know, I think I'm actually gonna call it a stream. Feeling super duper tired. My computer's being very slow. From SymbolNode to binary symbol tree, and I'm super tired. I don't feel like this is very entertaining. Nobody's hearing anybody, so I'm just gonna do my thing. Yeah, I might do this off stream. I might just do it when I'm less tired on Wednesday morning. We'll see. Depends on how timing goes. Anyway, I will catch y'all later. Take care.